Hey everyone, so we're going to go through and we're going to do a dihybrid cross together as an example. So if we start off with just recognizing what dihybrid is, we want to look at the root word. So di means two. So we've been doing monohybrid crosses, so that means we've been looking at one trait at a time. Now we're going to be going ahead and looking at two traits at a time. So in the virtual activity you were just working on, you saw this karyotype. And if we take a look, we're looking at two traits. Our two traits are basically the production of melanin, which is located at chromosome 15. And we're also looking at basically what produces kind of like our hair molecule. So deciding if it's going to be darker or red hair. And that's going to be located at chromosome 16. So looking at this individual's karyotype, they're heterozygous for both traits because they have one big A, one little a, one big R, and one little r. So now if we take this and we're just going to do a hypothetical parental cross, it tells us in our problem we're going to cross two people who are heterozygous for both of these genes. So we already saw what one heterozygous individual looks like. So we're going to set them both up right here. So what our next step does is it's going to ask us basically to come up with the combinations of the gametes that each parent can pass on. So we've been used to just looking at one trait at a time, but now looking at two, we have to come up with the different combinations that each gamete could be carrying. So a really important concept that I'm sure you guys have heard about in your math classes today or at some point is FOIL. So we are going to FOIL the different combinations to figure out what our gametes are. So we need to remember first what FOIL represents. So when we look at FOIL, we're talking about first, outside, inside, and last. So we're going to apply that to each of these genotypes. So if we're looking at this first parent right here, when we say that we're going to FOIL this genotype, when we say first, we're looking at the first letter in each gene combination. So that's going to be the big A here is our first, and that's going to take it over to our big R. So those are the first letters in each individual genotype if I'm to cover them up. So we're going to transfer that down here. So one combination is a big A and a big R. So both dominant alleles. Now we're going to move on to the outside. I always call it the bread of our sandwich. So we're going to look at the two most outer letters. So that's still going to be the big A. But now we're going to take that all the way over to our lowercase r. So if we write out that gamete combination, big A, little r. Now we move to the inner part, so kind of like the meat and all the goods of our sandwich. So if we look at the most inner letters, that's going to be little a, little r, or big R, excuse me. So we're going to go ahead, transfer that gamete combination down here. And then we have one more portion to FOIL. Those are going to be the last letters of each genotype. So that's going to be the little a here. And then if we look at the R combination, the little r. So those are our last two letters. We're going to transfer that into that space. So what this does is this goes ahead and it sets up our parental cross. So we're going to take all those gamete combinations, because what a gamete combination means is this is potentially the combos of alleles that each parent could pass on to their offspring, because law of independent assortment basically goes back to saying we don't really know at what point what they might pass on. This is all based off those probabilities. So we happen to have two parents who are heterozygous for the both traits. So if we were to go ahead and FOIL this again, if we just use it as a review, it's going to look really similar, but we still want to make sure we recognize first letter or first letters of each gene. So that would transfer down over here. the outside letters in our genotype, inner letters, and lastly, our last letters. Oop, I forgot to fill those in real quick up there. So now we're going to go ahead and we're going to combine all these alleles together. So if we're following kind of just etiquette, so we've talked about with Punnett squares before that the dominant letter should go first and that the recessive comes second. The other thing that I'm going to point out is see how in the genotype we kept our A's together and our R's together. We want to follow that same thing down in our Punnett square just so we don't start making funky genotype combinations. That's going to throw us off when we analyze it. So if we go ahead and we just start filling it in, so 2 big A's, 2 big R's, 2 big A's, a big R, and a little r. So we're going to go through and fill that all out together. So make sure if you need to slow this down to see where I'm kind of coming up with these combinations. But it's just going through, again, big A from here, big A from here, big R, little r, so on and so forth. Okay, so hopefully going through that, I know I did it quickly. So hopefully if you're checking my work, it adds up. So in this scenario, we're not going to do the genotypic ratio, especially with a heterozygous individual. There's lots of different combinations, but for some problems you'll have in the future, you'll need to write out those ratios. Instead, we're going to take a look at the phenotypic ratio. So we want to look for everybody who has tan skin and brown hair. So we'll represent it with these colors. So tan skin and brown hair are both dominant. So we're looking for any combination of basically having a big A. So whether it's, or I should just say a capital letter. So whether it's 2 or just 1, we need to remember law of dominance as long as 1 is present. That means we're going to have that dominant trait. So I'm just going to go through right now and I'm going to underline everywhere we see just a capital A right now, because that's going to represent all of our individuals who are going to end up producing melanin to have tan, darker skin. Now I'm going to go through and do the same thing, but with basically green, to find all of our locations of just a capital R, which is going to end up producing our darker hair. Okay, so just from doing that, I want to look at every spot that has both basically a red and a green underline. So if we were to go ahead and count those up, 1, 2, 3, 4, 5, 6, 7, 8. I think I'm missing one. Let's double check. 1, 2, 3. Oh, I'm missing one right here because I didn't underline it. Oops, sorry guys. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write it out as 9. It technically would be 9/16. That's a ratio. So going through and kind of the combination I just did of underlining or some type of symbol helps when it gets this complicated. Because you can even see that I missed one while we were going through there. So kind of just lesson learned, really wanting to make sure we're catching everything. So we found all of our genotypes that are going to code for the phenotype tan and brown hair. Now we're going to go through and let's underline red hair is going to be blue. Should have done it in a red pen. Missed opportunity. So I want to find everywhere where there's 2 lowercase r's to represent our recessive red hair. So we have one here, 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 and I don't think I missed any that time. So what we want to go ahead and do is find, again, all the individuals with tan skin and red hair. So that's going to be 1, 2, and 3. So 3 out of 16 are going to have that combination of a dark skin complexion and red hair. Lastly, or not lastly, but the next one we'll do is we'll switch over to fair skin and brown hair. So now we're looking for the combinations of 2 lowercase a's. So we have one here, 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 and here. But we're still looking for the combination of fair skin and brown hair, which all 3 of those are real close to one another in that combination. So that is also 3 out of 16. And then our final one that we're looking for are individuals with fair skin, red hair, which is only this box right here. So 1 out of 16. So if we go ahead and we check our work, because if there's 16 boxes, we want to make sure that adds up. So if we have 9 plus 3 is 12, plus another 3 is 15, plus that last one is 16, we can see that all of these add up. So typically, not typically, always I should say, when you have 2 people who are heterozygous, the combination, the ratio is always going to be a 9-3 to 3-1, which is why I knew I missed that one individual. But hopefully kind of just going through this video helped you see how to set it up. Crossing 2 individuals who are heterozygous for both traits is always going to be the hardest combination of a dihybrid. So what you guys are going to go through and do now is try some examples on your own. So if you need help, just ask, but hopefully this video is helpful. Bye, guys.